We are now doing differentiation. This is where the marks are at. This is where you do not miss a single mark. Let's do this. All right. So let's look at the rules first according to the formula sheet. If I have the function y equals to ax exponent n from even level 3, you know that dy dx equals to, it's the power rule, n times an, then x, n minus 1. This is the power rule. So we take the n down, multiplied by the coefficient of x, then again subtract 1 from the n. Let's take an example. If I have y equals to 3x squared, then dy dx will be 2 times 3 is 6, x, 2 minus 1, this is 6x. All right. Okay. All right, now looking at y equals to sine x, what's the derivative? Dy dx of sine x is simply cos x. There's no example for that. All right, the same way y equals to cos x, dy dx will be negative, the derivative of cos x is negative sine x, coming to cot, the derivative of cot is negative cos x squared x. A derivative of tan x, this will be sec squared x. All right. Now looking at this one, y equals to exponent x. What's the answer there? The answer is simply that it does not change. Y dy over dx is simply e exponent x again. All right. Now y equals to ln x. What's the derivative for ln x? The derivative for ln x is 1 over x. All right. Now we come to this one. Y equals to a sine x kx. So now our sine can be sine, cos, tan, or cot. Our sine has a coefficient, and the x also has a number before it. So what do we get for that? Then you are going to have dy over dx. For this one, you are going to multiply the k by the a, and I get ak, a times k, then sine kx. So simply you multiply the k by the coefficient of sine. Same here, my a looks like a 9 again. So a e exponent ekx exponent kx, then you are going to have dy dx equals to ak. So k is going to multiply the coefficient of e power x. All right, and k is still there, still remains. And then with ln, dy over dx here you are going to simply have, so literally here you are going to have, how do I put it, this one is going to simply be a over x. So the k doesn't make a difference. It's a over x. If a is 1, then you'll have 1 over x, which is the case here. Okay, let's do examples for this 3. This 3 will need a bit of examples. Let's have y equals to, thinking on the right sign here. Goodness, look at my sign, guys, here. Oh, I'm not going to start the video over. I'm changing now. Guys, doing this thing is a lot of work. You cancel so many videos and start afresh. So I'm not gonna cancel it. I'm gonna change here. All right. Then what is dy over dx? It's gonna be 2 times 3, which is 6 sine 2x. That's for number 1. So this is for number 1. Then let's look at this one. Let's have y equals to 7 e exponent 3x. Then what will I have? I will have dy dx gives me dy over dx is equals to 3 times 7. 3 times 7 is 21 e exponent 3x. All right, now with lane, let's say this one is for this. With lane, let's have y equals to 6 lane I don't know, 3x. I'm loving my 3x, I guess. All right, then what is my dy dx? It will be simply be 6 over x. The 3 does not make a difference. All right, going forward, we have our product rule, which says if I am multiplying 2 functions, g of x times f of x, let me write it the way you are used to it, f of x first times g of x. If I am multiplying the 2 functions, then their derivative I am going to first differentiate f, leave g as it is, plus now I am going to leave f as it is and differentiate g. That's our product rule. We should have an example in what we are going to do later. Now going to the quotient rule. So here we are dividing. So here, if I have f of x over g of x, then when I look for the derivative, it's going to be, you're gonna differentiate then g first times f of x minus, then here g remains the same, then you differentiate f of x, you'll decide how to put them, then all over gx all squared. That's our quotient rule. Then our This is not our product rule. This is our chain rule. This is a chain rule. Okay, chain rule, what does it say? If I have a function f of x to the power of something, then the derivative of that function I am going to, in a way, use the power rule. I'm going to say n times. So I'm going to first do the power rule and then differentiate the inside. So I'm going to do the power rule, leaving it as it is, and then differentiate the other side. What does it mean? I am going to have n times this, times the whole function, n times f of x, then power, now n minus 1, literally the power rule. Then you are going to multiply this now by the derivative of the inside function, f prime of x. So those are our rules. What else do we need to know before we start with differentiation? So literally this video is going to be